Most Toyota drivers spend hundreds at the dealership chasing better throttle response. But here is what they do not know. There are simple, cheap fixes under $15 that your Toyota is practically begging you to use. These are not modifications. These are factory-level corrections that restore what your engine lost over time, and once you apply them, the difference is immediate. Let's get into it. Hack number 1. Clean the mass airflow sensor with a $7 spray can. The mass airflow sensor sits inside the intake air duct, directly behind the engine air filter housing. It is a small component with a delicate wire filament that measures exactly how much air enters the engine. The engine control unit uses that reading to calculate the precise fuel mixture every single second your engine runs. Here is the problem. Over time, that sensor collects oil vapor, fine dust, and microscopic debris. The air filter did not catch. A contaminated mass airflow sensor sends slightly inaccurate air readings to the engine control unit. When the engine control unit receives bad data, it delivers the wrong amount of fuel. The result is hesitation off the line, sluggish mid-range response, and an engine that feels lazy even when you press the gas hard. A single can of CRC mass airflow sensor cleaner costs around $7 at any auto parts store. You unplug the sensor, spray it gently, let it dry for 15 minutes, and reinstall it. No tools are needed beyond a basic screwdriver. Toyota technicians who see clean mass airflow sensors consistently report noticeably crisper throttle behavior. The engine control unit starts receiving accurate air data again, recalibrates fuel delivery within a few drive cycles, and the throttle response sharpens immediately. This is the single most overlooked fix for soft throttle feel on high-mileage Camry, Corolla, RAV4, and Tacoma engines. Hack number 2. Replace the engine air filter for under $15. The engine air filter lives inside the rectangular air filter housing, which sits at the top of the engine bay on most Toyota models. It looks simple. It does not act simple. Every bit of air your engine breathes passes through that filter before it reaches the mass airflow sensor and the throttle body. A clogged or collapsing air filter restricts airflow at the exact moment the engine demands it most, during acceleration. When you press the throttle, the engine calls for a surge of air to mix with more fuel. A dirty filter chokes that surge. The result is a throttle that feels delayed, mushy, and disconnected from your foot. A fresh OEM equivalent paper air filter restores full airflow in under 5 minutes. No tools are required on most Toyota models. The housing clips open by hand, the filter drops in, and the difference is felt on the very next drive. For under $15, you are removing a physical restriction from the breathing system of your engine. Clean air means cleaner combustion, better fuel response, and an engine that reacts when you ask it to. Toyota recommends replacing the engine air filter every 15,000 to 30,000 miles. Most owners go twice that distance without touching it. Hack number 3. Clean the electronic throttle body with a $6 cleaner. The throttle body is the gateway between the intake air system and the engine. On modern Toyotas, it uses an electronic actuator controlled by the ECU to regulate exactly how much air enters the engine when you press the accelerator pedal. Inside the throttle body is a round butterfly valve that opens and closes thousands of times per drive. Over time, carbon deposits and oily residue from the positive crankcase ventilation system build up around the edges of that valve and on the throttle bore walls. When deposits accumulate, the butterfly valve cannot open as freely or as precisely as the ECU commands. The ECU asks for 40% throttle opening. The dirty valve delivers 35%. The engine hesitates. You feel that hesitation as a lag between pressing the pedal and the car actually responding. CRC Throttle Body Cleaner costs around $6. Spray it onto a clean rag, wipe the inside bore of the throttle body, and work the butterfly valve by hand while cleaning around its edges. Do not spray directly into the throttle body while the engine is running on electronic throttle systems. After cleaning, Toyota requires a throttle position. Relearn. Simply disconnect the battery for 5 minutes, reconnect, and allow the car to idle undisturbed for at least 10 minutes. This allows the ECU to relearn the throttle position sensor baseline and recalibrate the exact voltage that corresponds to closed throttle. Owners who perform this cleaning and relearn consistently describe the result as the car feeling new again. Hack number 4. Perform a full throttle position sensor. Relearn after any battery work. This one costs nothing but time, and it fixes more cases of poor throttle response than any part ever could. Every Toyota with electronic throttle control uses a throttle position sensor to tell the engine control unit exactly where the butterfly valve sits at any given moment. That sensor has a baseline, a 0 position. The engine control unit learns that baseline over time and uses it to calculate throttle response curves, idle quality, and fuel delivery. When the battery is disconnected for any reason, that learned baseline is lost. The engine control unit reverts to a factory default that may not perfectly match your specific throttle body's wear pattern. The result is a throttle that feels vague, hesitant at low speeds, or slightly delayed compared to what you remember. Start the engine cold. Allow it to idle completely undisturbed for 10 full minutes. No air conditioning, no radio, no blipping the throttle. During that time, the engine control unit maps the throttle sensor signal back to the correct baseline for your specific vehicle. After the relearn, take the car on a slow drive that includes gentle acceleration from a stop, highway speeds, and a complete deceleration. Within 2 to 3 drive cycles, the engine control unit updates its fuel and throttle maps fully. This procedure is free. It is one of the most effective throttle response fixes Toyota technicians perform after any electrical service. Hack number 5. Replace the positive crankcase ventilation valve for under $10. The positive crankcase ventilation valve, commonly called the PCV valve, is a small component typically found on the valve cover or in a hose running between the valve cover and the intake manifold. It looks like a simple plastic check valve, but it plays a critical role in throttle response that almost no one talks about. The PCV valve controls how crankcase pressure is managed inside the engine. When combustion gases escape past the piston rings, they pressurize the crankcase. The PCV valve routes those gases back into the intake manifold to be burned cleanly. If the PCV valve clogs or sticks, crankcase pressure builds excessively. That pressure pushes against the piston from below, creating resistance every time the piston moves down during the intake stroke. Your engine is working against itself. The result is reduced vacuum signal to the intake, sluggish throttle response, rough idle, and in severe cases, oil being pushed through seals. A replacement PCV valve for most Toyota 4-cylinder engines costs between $6 and $12. The swap takes under 5 minutes with no special tools. Once replaced, the engine breathes and cycles pressure the way it was designed to. Throttle feel becomes more direct, idle smooths out, and the engine regains a crispness that a dirty PCV system was silently stealing. If you've made it this far, hit that thumbs up and subscribe. It helps me bring you more of this honest, practical Toyota content every week. Hack number 6. Inspect and clean the idle air control circuit. On older Toyota models with cable-driven or semi-electronic throttle systems, the idle air control valve manages the amount of air that bypasses the closed throttle plate at idle. On newer electronic throttle models, this function is handled through the throttle body itself, but the passages and ports still exist in the intake manifold. Carbon buildup in these idle air passages restricts airflow during the transition from idle to light throttle input. This is the exact moment when throttle response matters most in everyday driving. When you ease onto the gas from a stop, the engine calls for a smooth transition from idle airflow to active throttle opening. Carbon-restricted passages create a stumble, a brief hesitation, or a flat spot right at the beginning of that transition. Spraying intake manifold cleaner into the idle circuit ports and allowing the engine to process it through a short drive cycle dissolves those carbon deposits. The transition from idle to throttle becomes seamless. That stumble disappears. Many drivers mistake this symptom for a fuel injector problem or a transmission hesitation, when it is simply a blocked idle air passage that costs almost nothing to clean. Hack number 7. Check and clean the intake air temperature sensor. The intake air temperature sensor is a small probe located inside the intake air duct or inside the intake manifold, and most Toyota owners have never noticed it exists. Its job is to measure the temperature of the air entering the engine. The Engine Control Unit, ECU, uses this reading to fine-tune ignition timing and fuel delivery. Cold air is denser and carries more oxygen, so the ECU advances timing slightly. Hot air is less dense, so the ECU pulls timing back to prevent knock. A dirty or coated intake air temperature sensor sends inaccurate temperature readings to the ECU. When the ECU thinks incoming air is hotter than it actually is, it pulls timing back unnecessarily. The result is reduced combustion efficiency, softer throttle response, and a slight power reduction that gets worse in warm weather. A can of electrical contact cleaner costs around $5. A light spray on the sensor tip removes the film of oil and grime that accumulates over time. Once clean, the sensor reports accurate temperatures, the ECU restores proper timing advance, and throttle response improves noticeably, especially during warm weather driving when this sensor is most active. Hack number 8. Test the manifold absolute pressure sensor signal. The manifold absolute pressure sensor, often called the MAP sensor, is mounted directly on or near the intake manifold. It reads the pressure inside the intake manifold to help the ECU understand engine load at any given moment. Under light throttle, intake manifold pressure is low and the engine is barely working. Under heavy throttle, pressure rises sharply as the engine demands more air and fuel. A MAP sensor that is contaminated with oil vapor or moisture delivers a slightly delayed or inaccurate pressure signal. The ECU uses this signal to decide how aggressively to deliver fuel during acceleration. A slow MAP sensor signal creates a throttle response that feels vague, unresponsive, or as if there is a half-second delay between your foot and the engine. Cleaning the MAP sensor port and the sensor tip itself with electrical contact cleaner takes less than 5 minutes. On many Toyotas, the sensor unplugs from one connector and is removed with 2 bolts. A clean MAP sensor gives the ECU the sharp, accurate pressure data it needs to respond immediately when you press the accelerator. The throttle sharpens, the hesitation clears, and the engine reacts the way a Toyota is supposed to. Hack number 9. Check vacuum lines for cracks and leaks. Vacuum lines are small rubber hoses that run throughout the engine bay of every Toyota. They connect the intake manifold to sensors, actuators, brake boosters, and emissions components. They cost almost nothing. A cracked or split vacuum line is one of the most common hidden causes of poor throttle response on any Toyota with more than 80,000 miles. When a vacuum line cracks, outside air enters the intake system at an unmetered point. The engine control unit is not aware of this extra air, and it cannot account for it in its fuel calculations. The result is a lean air-fuel mixture that causes hesitation, stumbling during acceleration, a rough idle and throttle response that feels inconsistent or erratic. Inspecting vacuum lines is free. Look for brittleness, cracking near hose connections, or a hiss coming from the engine bay during idle. Replacement hoses are sold by the foot at any auto parts store for under $5. Replacing a cracked vacuum line takes minutes and can restore throttle response that no cleaning procedure would have fixed because the root problem was never contamination. It was a leak. Hack number 10. Clean the fuel injectors with a tank-based cleaner. Fuel injectors on Toyota engines are precision components that deliver atomized fuel directly into the intake port or combustion chamber. Over time, carbon deposits and fuel residue accumulate on the injector tips, changing the spray pattern from a fine mist to an irregular stream. When the spray pattern degrades, fuel does not atomize completely. Incomplete atomization means slower combustion, and slower combustion means the engine does not respond as quickly to throttle input. The power stroke starts a fraction of a second later. That fraction of a second is what drivers feel as throttle lag. A quality fuel system cleaner like Chevron Techron or BG44K runs between $8 and $15 per bottle. Add 1 bottle to a near-empty fuel tank and fill with fresh fuel. Drive normally. Over the next 200 to 300 miles, the detergent chemistry dissolves deposits from injector tips, intake valves, and combustion chambers. Toyota engineers designed these engines with tight injector tolerances. When those injectors spray cleanly again, combustion sharpens, throttle response snaps back, and the engine feels noticeably more alive through the entire RPM range. Hack number 11. Disconnect and reconnect the battery for an ECU adaptation reset. This final hack costs absolutely nothing. It is often the last step that ties every other improvement together. Toyota ECU units learn and adapt over time. They adjust fuel trims, throttle response curves, and idle parameters based on the history of how the engine has run. If that history includes contaminated sensors, dirty injectors, restricted airflow, or vacuum leaks, the ECU has adapted its fueling strategy to compensate for those problems. When you fix the underlying issues, the ECU sometimes holds on to its old compensations. The throttle may still feel slightly soft because the ECU is still trimming fuel delivery based on outdated data. Disconnecting the negative battery terminal for 5 to 10 minutes clears those learned adaptations and performs a reset. The ECU then starts fresh when you reconnect the battery and perform a proper idle relearn, followed by a gentle drive cycle. The ECU builds a new set of adaptations based on a clean, properly functioning engine. The result is a throttle response that reflects all of the improvements you made, not the compromised state the engine was in before you started. Here is the full picture. Throttle response is not one thing. It is the result of clean sensors giving accurate data, unrestricted airflow reaching the engine, a clean throttle body responding instantly to commands, and an ECU working with real-time accurate information. Every single hack in this video attacks one part of that chain. Together, for under $15 and less than an afternoon of work, they restore the system to the way Toyota built it. Not modified, not upgraded, just clean, accurate, and working as intended. The drivers who understand this get more response, better fuel economy, and a Toyota that feels sharp for another 100,000 miles. The ones who do not keep wondering why the car feels a little off and never quite find the answer. If you are enjoying this content, go watch the next video where I break down the exact maintenance steps that push Toyota engines past 300,000 miles.